Myself Rupanjali Goswami. In this video, we shall learn the method of undetermined coefficients. So consider the non-homogeneous differential equation a naught yn plus a1 yn minus 1 plus up to an minus 1 y prime plus an y is equal to fx, where all these a naught, a1, a2 up to an are constants, and the non-homogeneous term f in general is a non-constant function of x. Then the general solution of 4.35 can be written as yc y equal to yc plus yp, where yc is the complementary function, yc is complementary function and yp is particular integral. Okay, and what is yc? Yc is actually solution of the general solution of the homogeneous equation a naught yn plus a1 yn minus 1 up to an minus 1 y prime plus an y is equal to 0. And this homogeneous equation is obtained just by putting 0 on the right hand side of the considered equation. And what is yp? Yp is particular integral, and that is actually any solution of the considered equation 4.35 containing no arbitrary constants. Containing no arbitrary constant. And we already have learned how to find complementary function, because complementary function is actually the general solution of a homogeneous equation obtained from the given equation, given non-homogeneous equation, just by putting 0 on the right hand side of the given equation. Now we considered the method of undetermined coefficient. For that, let us consider one example. Say y double prime minus 2y prime minus 3y is equal to 2e to the power 4x. So let us find its particular integral first. Now to find a particular integral means a solution y of this equation such that if I differentiate that y, which is a function of x, twice minus if I multiply the first order derivative of that function, which is known as particular integral, by 2 minus 3 into the function gives the result 2e to the power 4x. So it is reasonable to take the particular integral yp in the form ae to the power 4x. Why it is so? Because if I put yp is equal to ae to the power 4x, then if I differentiate yp twice, then from that if I subtract 2 times its first order derivative minus 3 times itself, then that will result a function of the type 2e to the power 4x. That's why we take this yp as a to the power 4x. And what is a? Here a is a constant and it is actually known as undetermined coefficient. Its name is undetermined coefficient. So a is known as undetermined coefficient. Now to find what is a, till at this moment we do not know what is the value of a, but we need to determine it. For that, let us differentiate yp with respect to x. Then I shall get 4a e to the power 4x. Then we differentiate yp prime again to get yp double prime. Then it is 16a e to the power 4x. Now substitute these two, yp prime, yp double prime and yp in this equation 4.36. What will I get? Let us see. Substituting in 4.36, we get 16a e to the power 4x minus 8a e to the power 4x minus 3a e to the power 4x is equal to 2e to the power 4x. Now let me know what is what is the interval in which all the coefficients present on the left hand side, all the coefficients means coefficient of y double prime, it is obviously 1 is there, is it? Then coefficient in the second term 2 minus 2, coefficient in the third term minus 3, all these are real constants. And also you see the function on the right hand side, which is actually non-homogeneous term, and we know domain of this function is R. So here the interval in which the solution will be valid will be actually R. Interval is minus infinity plus infinity. Okay, so here what we have seen, this is a solution which is valid. Yp is a solution which is valid for all x lying in R. So just I need to determine the set or subset of R in which the coefficients a0, a1, a2 and f are continuous, and definitely in R all those three coefficients and the non-homogeneous term which is a function of x are continuous is R. Okay, therefore the left hand side will give 8 plus 3 is 11, so 5a e to the power 4x is 2 e to the power 4x, and this is true for all x in R. This is true for all x in R. Okay, that gives 5a is equal to 2 because it is true for all x. And so on the left hand side we have e to the power 4x, on the right hand side e to the power 4x, they are non-zero, so cancelling them we get this, and a is 2 by 5. Thus the particular integral yp is, therefore yp is 2 by 5 e to the power 4x. Now let us consider another one equation. Consider y double prime minus 2y prime minus 3y is equal to, say, 2 e to the power 3x. So it is 4.39. Earlier one was 4.36. Now here we shall find a particular integral of this equation by the method we have discussed earlier, because we have seen there is 2 e to the power 3x on the right hand side. So I have to take a particular integral which is a function of x, yp, a function of x, such that its second order derivative minus 2 times its first order derivative minus 3 times itself is equal to 2 e to the power 3x. So it is reasonable to take yp as a e to the power 3x, then where a is a constant which is known as undetermined coefficient. Now as usual, let us find yp prime. It is equal to 3a to the power 3x, and yp double prime is equal to 9a to the power 3x. Then now substituting in the equation 4.39, we get 9a e to the power 3x minus 2 into 3a e to the power 3x minus 3 into a e to the power 3x is equal to 2 e to the power 3x. This gives 0 into a e to the power 3x is equal to 2 e to the power 3x. So now on the left hand side we have 0. Okay, on the left hand side we have 0, and on the right hand side we have 2 e to the power 3x. And this is true for all x in R, because here we observe that the coefficients on the left hand side, a0 is 1, a1 is minus 2, and a2 is minus 3. All these are real constants which are continuous in R. And also consider the non-homogeneous term which is a function of x, that is also a continuous function on R. So the solution yp is defined for all x belonging to R, and we have seen this is true for all x lying in R. Okay, and we know that for any real x e to the power thrice x is non-zero. So it is not possible that 2 times a non-zero real number is equal to 0. So I can say which does not hold for any real x. Now in the earlier case we obtained the value of a, but here we got an absurd result. 0 is 2 e to the power thrice x, which is true for all x in R. It is not possible. So why we are getting such a situation? Why we are facing such a situation? The point we shall find out, or we shall find out the reason behind it. Now, if I consider the equation 4.36 and equation 4.39, let me show once what is equation 4.36. This one, 4.36. It is y double prime minus 2y prime minus 3y is equal to 2 e to the power 4x. So what is there on the left hand side of the equation? Y double prime minus 2y prime minus 3y. Now let us see what is there on the left hand side of equation 4.39. It is again y double prime minus 2y prime minus 3y. So equation 4.36 and 4.39 are almost the same because their left hand sides are same. But there is a difference on the right hand side, because in the earlier equation 4.36 there was 2 e to the power 4x on the right hand side, but here in this equation we have 2 e to the power 3x on the right hand side. So there is the difference in the coefficients of x in the exponent in both these two terms, non-homogeneous terms. But in the first case we have got yp as 2 by 5 e to the power 4x, but in the second equation we have got yp, we do not get a value of a. So why this is happening? For that, let us find the complementary function of both the two equations. Obviously, both the two equations will have the same complementary function because their left hand sides are same. Both the equations have the same left hand side. Okay, so to find complementary function, we are to consider y double prime minus 2y prime minus 3y is equal to 0. And after that we are to find the auxiliary equation of this equation, and it is definitely m square minus twice m minus 3 is equal to 0, which can be solved, and we can get value 3n minus 1. So from this line we can say that e to the power 3x and e to the power minus x are two linearly independent solutions, of this homogeneous equation y double prime minus 2y prime minus 3y equal to 0. That means in the later case, in the later equation 4.39, while we try to find the particular integral yp, we wrote it as a e to the power 3x. And you see, as e to the power 3x is a solution of the homogeneous equation, this one. This is the homogeneous equation. And to get the complementary function, we should consider the homogeneous equation. Okay, homogeneous equation obtained just by putting 0 on the right hand side of the given equation. That we did here. And as e to the power 3x is a solution of this homogeneous equation, definitely a to the power 3x also will be a solution of that homogeneous equation, because a here is a constant only. Okay, so that solution is already been considered while we find the complementary function. And as a result, if I take yp is equal to a to the power 3x, then that will not work. That is the point. That will not work. And as a result, what we shall do, let me show one example. In case of solving homogeneous equation, we found the auxiliary equation. Suppose the auxiliary equation has two repeated roots 2. Then what are the solutions of the homogeneous equation? We take one is e to the power 2x and other is x e to the power 2x. And after getting those two, what we did? We take the linear combination of these two linearly independent solutions, and that will be the general solution of the homogeneous equation. That was the method, and here we are sure that e to the power 3x is a solution of the homogeneous equation. So we cannot take the particular integral as a e to the power 3x, because once e to the power 3x is a solution of the homogeneous equation, that implies a e to the power 3x is also a solution of the homogeneous equation, means this solution is already been taken. That's why we shall take yp as a into x e to the power 3x. This concept is being used. While one solution is e to the power 3x, we take the other solution as x into e to the power 2x, just like that. As one solution is a e to the power 3x, that is already been considered while we find complementary function. So the other solution yp we take as ax e to the power 3x. So to get the particular integral of 4.39, that means y double prime minus 2y prime minus 3y is equal to 2e to the power 3x, that was 4.39. To get particular integral, we take yp is equal to ax e to the power 3x. So that is the trick, or that is the thing that you should learn here. Okay, so just you have to observe whether this e to the power 3x is a solution of the homogeneous equation y double prime minus 2y prime minus 3y is equal to 0 or not. If yes, then we shall take the particular integral yp as ax e to the power 3x. If not, if e to the power 3x is not a solution of y double prime minus 2y prime minus 3y equal to 0, then we can take yp particular integral as a e to the power 3x. Then now we proceed. Let us differentiate with respect to x once and twice. Then I shall get 3a x e to the power 3x plus a e to the power 3x. Then if I differentiate it again, then I shall get yp double prime, and that is 9ax e to the power 3x plus 6a e to the power 3x. Now substituting the expressions for yp double prime, yp prime, yp, they are on the left hand side of the equation 4.39. So substituting this in 4.39, we get, because yp is a solution, yp that is simply a notation. So yp, it is a solution. So we put those three expressions there in the given equation, and that will give 9ax e to the power 3x plus 6a e to the power 3x minus 2 into 3ax e to the power 3x plus a e to the power 3x minus 3a x e to the power 3x is equal to 2 e to the power 3x, and that after simplification will give 9a minus 6a minus 3a multiplied by x e to the power 3x plus 4a e to the power 3x is equal to 2 e to the power 3x, and that gives 0 x e to the power 3x plus 4a e to the power 3x is 2 e to the power 3x, and this is true for all x in R. And so we have, this will give a is, I can write 4a is equal to 2, this will give a is equal to half. Then thus the particular integral of yp of 4.39 is, yp means particular integral of 4.39 is yp is equal to half x e to the power 3x. Okay. So if I want to write, therefore the general solution of y double prime minus 2y prime minus 3y is equal to 2e to the power 4x is y equal to yc plus yp, but yc was c1 e to the power 3x plus c2 e to the power minus x, because we already obtained e to the power thrice x and e to the power minus x are the two solutions of the homogeneous equation. So complementary function is c1 e to the power thrice x plus c2 e to the power minus x, and particular integral in this case was 2 by 5 e to the power 4x. And the general solution of y double prime minus 2y prime minus 3y is equal to 2 e to the power 3x is y equal to yc plus yp is c1 e to the power 3x. Complementary functions of both the two equations are the same, but particular integrals are different of x e to the power 3x. And here c1 and c2 are arbitrary constants. So this way we can solve a non-homogeneous equation. Now let us discuss the method of undetermined the coefficient method. And before we discuss the method, we define some terms. So let us first define UC function. UC function. So we call a function a UC function if it is either number 1, a function defined by one of the following. One of the following. Roman 1, x power n, where n is a positive integer, or 0. Roman 2, e to the power x, where a is a constant which is non-zero, not equal to 0. Number 3, sin bx plus c, where b and c are constants and b not equal to 0. Because if b is 0, then you will get a constant. Sin c is a constant. But we are writing here a function of x. And number 4, cos of bx plus c, where b and c are constants and b not equal to 0. So a function which is one of these 4 types is called a UC function. Or number 2, if I consider finite product of the functions defined in Roman 1, Roman 2, Roman 3, Roman 4, then also it is a UC function. So a function defined as a finite product of 2 or more functions of these 4 types. So consider examples. Say example 4.30. So let us write examples of UC function of the four basic type, say 1, 2, 3, 4 of the definition are, first type was x to the power n. So if I take in particular n equal to 3, then I shall get x cube. Then second type was e to the power ax. So if I take a equal to -2, then it is of second type. Then third type sin bx plus c. So if I take b is 3 by 2, c 0. Then cos 2x plus pi by 4, means here b is 2 and c is pi by 4. So this is of type 1, this is of type 2, this is of type 3, this is of type 4. Then consider another one example, which is actually finite product of UC functions of type 1, 2, 3, 4. So let us consider example of UC function defined as finite products of two or more of these four basic types are, say, x square e power 3x. X square is of type 1, e to the power 3x is of type 2, then multiply them, it is the finite product. So this is also an UC function. Then x cos 2x. So it is the product of x and cos 2x. So x is of type 1 and cos 2x is of type 4. Done. Then e to the power 5x sin 3x. It is of type 2 and it is of type 3. The finite product we are considering. Sine of 2x cos of 3x. So sine 2x is of type 3 and cos 3x is of type 4. So it is the finite product of type 3 and type 4. Then if I consider, say, x cube e to the power 4x sin 5x, then it is product of three functions, three UC functions. X cube is of type 1, e to the power 4x is of type 2 and sin 5x is of type 3. So these are also UC functions. So here we should note down one point. Point is that the method of undetermined coefficients applies when the non-homogeneous function f in the differential equation is a finite linear combination of UC functions okay. Observe that given a UC function f, each successive derivatives of f is either itself a constant multiple of a UC function or else a linear combination of UC functions. So let us stop here. In the next video we shall learn more on this method.